Alright, this is the video for solving one-step equations. You should have this piece of paper next to your inverse operations. We're on page 45, so label page 45. Go ahead and glue this in. I've already got it done. And then go back to your table of contents, and we're going to put page 45, solving one-step equations. Okay. Alright, so you see this picture of a scale here. We talked about an equation as something with an equal sign. Picture the scale, the equal sign being right in the middle. Okay, so we have to keep it balanced. Alright, so anything we do to one side, we have to do to the other. That's just a good visual for you. So, first we're going to talk about what the goal is when you're solving a one-step equation. So the goal is to get the variable by itself. Okay, so if there's the variable x or n or c or whatever letter it is, we're trying to get it by itself to figure out what it equals. And we're going to do this by using inverse operations, which you should know what those are from the last video. Okay, so that's why I have those handy on the page right next to you. Okay, so there's another little reminder. We're going to move things away from the variable, which will lead us to having the variable by itself. Okay, so we've got 6 examples down here. So we're just going to start with addition right here. So our equation is x plus 3 equals 7. The first thing I always want you to do is draw a wall down the equal sign. Okay? That's kind of like the middle of your balance. So everything you do on one side, you have to do to the other. Okay? And then I want you to box the variable. Where's your letter? Put a box around it. That is to remind you that we're trying to get that by itself. Okay? Alright, from there you have to figure out what operation is being done to this number in order to get it by itself, and it's a plus 3. So you look back over here at your inverse operations. The inverse of add is to subtract. So, back over here, if it's plus 3, we're going to do minus 3. And then if I do that to one side, I have to do the exact same thing to this side. Okay, so plus 3 minus 3 cancel out, and then all we're left with is x. Bring down your equal sign, and then 7 minus 3 would be 4. So that means x equals 4. Okay, now another thing about solving equations is there's really no excuse to getting these wrong because you can check it every single time. So we're going to put a little check down here. How you do that is you take your answer and you substitute it in for this equation and see if it fits. So if x equals 4, it would be 4 plus 3 equals 7. So 4 plus 3 is 7, which equals 7. So check, that means that's correct. Okay, moving on. This one's addition again. So again, we're going to draw a wall down the equal sign, and we're going to box the variable to know that's what we're trying to get by itself. Now, this is addition, but if you notice here you have a negative number, so we need to do the opposite of that minus and add 5 in order to cancel it. If I subtract 5, I'm just going to have negative 10 over here. So it's always what you need to do to get to 0. So then if I do that to this side, I have to do it over here as well. So these cancel. Bring down your x. X equals 2 plus 5, which would be 7. Okay? Alright, now we're going to check it. So you take this and you substitute it back into your equation. So you write negative 5, oh, let's write check first. Okay, so negative 5 plus 7 instead of x equals 2. Now this requires integers, so you got to kind of remember back to negative numbers. So we've got negative 5 and positive 7. They're different signs, so we have to subtract. Okay, and we keep the sign of the bigger number, which is positive. So 2 equals 2. So check, that means that is correct. Alright, moving on. This one is subtraction, so we're going to have to do a different inverse operation. So draw a line down your equal sign always. Box your variable. Okay, now I have a minus 2. So what's the opposite of that? Would be plus 2. That's what would cancel it. So I have to do it to both sides. So minus 2 plus 2 cancel, and all I'm left with is x equals 4 plus 2, which is 6. Okay, and then we're going to check. So instead of instead of x, we're going to put 6 minus 2 equals 4. 6 minus 2 is 4. 4 equals 4. That means it's correct. If it's not correct, these are going to be different numbers, so they're not going to equal. So that's going to be a red flag until you need to go back and check what you did. Okay, moving down here to subtraction. Again, draw a line on the equal sign, box your variable. Okay, this is a little tricky. If you notice, we've got a minus in front of the x, and we're going to have to fix that in a little bit. So first, you have a positive 8 here, so the opposite of positive 8 would be to subtract 8 from that. Okay, so those cancel, but be careful, you have a negative x here. Don't just drop off that negative. Equals 5 minus 8. 5 minus 8 would take us to negative 3. This most simple way I can think to explain this is if this is negative, in order to cancel that, you're going to make the other side the opposite that it is. So if we're making x opposite, so negative to positive, we're going to make this one negative to positive. So x equals 3. Okay, now to check, we're going to substitute 8 minus 3 equals 5. 8 minus 3 is 5 equals 5. Check. That works. Alright, next is multiplication. So, remember that when a number and a letter are next to each other, it means they're being multiplied. So, draw your line, box your variable, and then figure out, okay, these are being multiplied, so what's the opposite of multiply is to divide. So we're going to have to divide both sides by 6. And to show that, we just draw a little fraction bar. So if you times 6 and divide 6, they cancel, and you're left with x equals, and this means 12 divided by 6, which would be 2. Okay, so we're going to check down here. Alright, we've got 6. Remember when we substitute, we have to put parentheses, or else it would look like 62. 6 times 2 is 12. 12 equals 12. Check, that works. Okay. Last one we have division. So remember, if you see a fraction like this, it's actually meaning to divide by 2. So the opposite, or first draw your line, and box your variable. Okay, so now you have division. Now you've got to do the opposite of that, which is to multiply. So over here we're going to do times 2, and over here we got to do the same thing. So times 2 divided by 2 cancel. Bring down the x. 4 times 2 equals 8. Alright, let's check. We've got 8 over 2 equals 4. So this means 8 divided by 2, which equals 4. 4 equals 4, so that works. Perfect. Alright, so just a couple reminders. I always want you to draw the line where the equal sign is, box your variable, and then first thing is figure out what would get rid of this, what would cancel out the number with the variable to get rid of it. And then always, always, always check, because there's no excuse to missing these, because you can always check your answers. Alright, go ahead and go practice.